So thank you, panel, very much for joining us here. What a fantastic set of presentations. I thought it was just fascinating all afternoon. Great work by everybody. So let's start off. We have an opportunity for sort of the big picture overview with everybody here at once. So do we have any questions from the audience about after we've heard it all? There's Dr. Good. Dr. Goodman. Okay.
Generally speaking, how much of the material that is put in recycling bins winds up in landfills? It's my impression that often materials that are not appropriate are put in these bins, and from a very, very unscientific survey, when there are rows of these bins, it seems to me that people often walk by and toss something in to toss it in, but not really paying attention as to which one. Is this a problem? Is it increasing, decreasing?
So, yes, it's a problem. We probably about 5 years ago, I think nationally, our members were saying that it was about 25% contamination. So about a quarter of the bin was stuff that didn't belong in the bin. It's really a function of education and reinforcement. And so a lot of what was happening was the education had stopped, people had gone through an effort, educated people, and then they said, okay, people know, and so then they stopped doing it. What we found is education has to be done again and again, and so the more frequently it's done, the better people are, and that the areas that have better education programs do a much better job with it. So I think a very well-run program can have contamination in the single digits, and then a really poorly run program can have like up to 40%. I had a recent experience at where I live, where they started accepting food waste in bins, and again, it was next to a recycling bin and a trash bin, and I went to take my food waste composting from work into the bin, but it was locked, and it required an app to unlock it. And so that level of friction probably means that that's going to have really low contamination, because people aren't going to utilize that bin because it requires so much effort to use.
Anybody else? Okay, Jay, was that good?
I was going to kind of follow up on Jay's question, but from a slightly different angle. You know, I'm curious if anybody has an idea of what percentage of recycled plastics are actually used for food contact materials. Do we have a handle on that?
Okay, so when we look at PET and HDPE, it's only about 28% of the PET containers that are actually find their way to being recycled. We're still in single digits of all plastics, but that's all polymers, and there's so many different kinds. So the highest recycled concentrations are the PET and HDPE, but even those, it's less than 30%. Of those, less than half of that makes it back into bottles and jars. And that's not just food contact, that's also for the HDPE to make it back into bottles or jars. Most of it, over 50%, is still diverted into carpets or textiles, pipes, things like that.
Follow up, then I'm going to pass to, you know, just doing a little bit of homework for this symposium. I've noticed that several states now are passing these extended producer responsibility laws that are actually mandating a certain percentage of recycled plastics, I'm assuming other materials, to be used in some of the products that I think we're talking about here. Is that going to be feasible?
So what we're talking about is, so there's been extended producer responsibility laws for many, many years in Europe and Canada. In the US, we've had a number of extended producer responsibility laws associated with hard-to-handle materials, in particular things like mercury thermostats or paint, sometimes mattresses or tires. But for packaging, that has never really been subject to extended producer laws until the first laws was passed in Maine in 2022, or 2021, sorry. So Maine and California passed, no, sorry, Maine and Oregon passed in 2021, and then 2022, Colorado and California, and then this year we had a fifth state, Minnesota, get added. So right now we have 5 states that have packaging EPR. What this means is that the producers, that is the CPG companies, the consumer packaged goods companies, are responsible for paying for the end-of-life management for the packaging that they put out into the market. And so that could include 100% of collection, processing, and recycling, or it might not. It depends on the different state. Also, it might also require them to have recycled content mandates in there, but that's not necessarily required. Some states separate from them have recycled content mandates. So that would include New Jersey and California. Both have recycled content mandates where they say, okay, plastic bottles must have a certain percentage recycled content, and then they usually have it graduated. By 2025, you have a certain percent, 2030, 2035, and so on.
I have a question actually for Sean online. My question relates to the use of multi-layer packaging for food contact, where you would have a virgin layer on the inside, which actually contacts the food, and then in the middle or on the outside, you would have a recycled component. How does the FDA handle the potential migration through the layers, or is that not a concern, or is that not something that the FDA has seen from manufacturers of any of the plastics and packaging that you're seeing?
So, I mean, as I mentioned at the end in my presentation, that is one of the things that we actually have in our guidance about. If you didn't remove enough, you could put the recycled material as a non-food contact layer and a multi-layer. We have some information in our guidance on for PET, on what we consider based on the use temperature to be a sufficiently thick layer of virgin PET to limit the migration of any substances from the recycled layer that's not contacting food. We don't have similar information for other polymers. So really it comes down to having enough of a barrier in place that you would have no migration of contaminants that exceeds that threshold, that 0.5 parts per billion.
Yeah, sorry, follow-up. Thanks. So then, is that something that a manufacturer would have to come to the FDA and discuss in actually establishing what that sufficient barrier would be to prevent migration?
So in generally, no. Like I said, it's the manufacturer's responsibility to comply with things. These recycling, the recycling program is voluntary. No one is required to come to us at all. We would be happy to discuss with them what we, offer our opinion on what we think is a suitable barrier layer. If they had data to back that up, we'd be happy to review that and discuss with them whether we thought that was a suitable barrier. but just like with reviewing the recycling process to begin with, they're not required to come talk to us.
So
Norb,
we've got a question that came in online, and the question is, what percentage of the fees of EPR will go to education?
And it's really not a percentage of the fees, it's more a designation that they would have to do some education. So they would basically have to fund certain things, and to the extent that they determine what the costs are, they would have to fund it. Can I ask a question? Okay, this would be for, I think, all the speakers. One of the things that we have struggled with in the recycling industry are biodegradable additives, that nobody wants anything that's gonna, if we're gonna go through the process of recycling, anything that's gonna biodegrade is gonna be worse after that process. So perhaps if it goes back to a chemical recycling process, that might be mitigated, but to what extent are you still seeing these biodegradable additives occur?
I can just answer for advanced recycling. It's not, we don't, in our feedstock specification, we're not measuring for those particular, like, oh, here's the percentage of biodegradable additives. It will show up in other contaminants, and so we will limit it according to that, not necessarily the degradation products, because in pyrolysis, we don't worry about that.
So from a mechanical recycling standpoint, are you kind of thinking like that for polyethylene, like those like oxidants? I mean, that remains a large challenge, right? I mean, like the goal on the mechanical recycling side is to reduce the amount of chain scission that is going to cause the degradation in properties and so forth. And so we see that to a certain extent, and you know, some of those kind of can be viewed as a contaminant in the mechanical recycling stream. But there's a lot of the source control becomes very critical. So like that would be the chances for that to happen would probably be coming from a MRF material. And a lot of the recyclers are still trying to keep that kind of single source of materials. So.
do we have any comments on that question from our colleagues online?
I don't really have anything else to add on that one. So.
I'm sorry, say that again. You said you did not want to, you did want to comment?
No, nothing to add. Well,
Okay,
well
all right.
spoken by my colleagues there in person.
I concur with Reid there.
Okay.
I have a question for Dr. Curtzwiler, and that is in regard to the portion of your presentation where you talked about trying to determine worst case scenario, assuming 100% migration, and you ended up with a few different extraction methods, one of which I think was xylenes at 40 degrees centigrade. And so as a toxicologist, one thing I always think about is having things biologically relevant. So I was wondering if you've done similar extractions, trying to mimic real world situations where if it's a food contact polymer, scenarios where it may have different exposures, and to see what actually can be extracted in those circumstances, and if the list of compounds changed, and if so, what were the changes?
And that's a fantastic question, right? And that's going to be probably the most relevant one for chemical food safety piece. And that's where we're headed next. And so we still have a lot of these materials that are left. We're going to be converting them into a film so that way we can create these little circles, and so we can actually get true migration rates and diffusion coefficients of these different types of contaminants. But to your point, I mean, you know, chemistry is chemistry, like dissolves like, and so it needs to be able to go into something that's going to be soluble. And so generally we could use, you know, water, 10% ethanol, 50% ethanol, 95% ethanol. You know, we could do 3 or 4% acetic acid, and these are pretty common food contact simulants that we're going to be moving forward with. And so, and also to your point, the condition of use. I mean, is this going to be microwave? Is it going to be room temperature? The length of time of exposure? And so time and temperature are the two things that are going to be most important for migration. So come back to me in about a year. I'll have a better answer for you.
Other questions?
So two chemicals of concern that our customers are worried about are antimony and ethylene glycol in PET, but I didn't hear any of that in today's discussion. Are those things that you're monitoring for? We make packaging for high-fat, long shelf life applications.
And we've heard a lot of those too. With mainly what I was presenting on today was focused on the polyolefins. That seems to be recently for direct food contact a really hot topic. Antimony is coming back, as you just pointed out. And we've done some migration studies in water and didn't see a lot of antimony transfer. I mean, there's a reason why, and Dr. Fischer, you could probably speak to this better. Well, you definitely could speak to this better than I, but that they don't necessarily recommend having a metal salt present in the migration testing. Most of those kinds of metals tend to stay within the PET matrix and don't really have a very high migration potential that's relevant. For ethylene glycol, we haven't done a significant amount of like migration testing into the different food stimulants for that yet. So.
With the recycled, does it drive the levels up? Do you know?
So it depends on how the recycling process was done, right? So if it was solid state, for example, and it was pulling a vacuum at a high temperature, some of the things that could be driven off in addition to water could be the ethylene glycol. So that anytime you have a heat and vacuum, you're going to potentially remove some of those lower molecular weight potential migrants. And so I would assume that would then, reduce the chances for that to happen because you're also building molecular weight. And as that's kind of becoming a little bit more of a prevalent process that,
Hi, I have a question for Sean Fischer. Noticing the increased uptick in NOL submissions, is the FDA considering improved guidance on either effectively crafting the submissions to minimize your workload, or when a submission would be useful or not necessary?
That is absolutely what we are doing right now. I am actually in the process of drafting that guidance update right now. The current one we have out there is effectively from 2006. There was some minor technical updates that were done in 2021, so that's why there's a newer date on it. But the substantive content of it is from 2006. So we are looking at obviously updating our guidance to reflect the change that we've observed in what we're seeing. The 2006 guidance focuses on PET because that was what was coming in. So we're looking at updating the guidance to more directly address these other polymers that we're seeing, especially polyolefins. And then we're also looking at trying to update things so that, just like you said, are there submissions that we've reviewed enough times, certain scenarios, combinations of feedstock, recycling process and use that we've reviewed enough times over the last 30 plus years that we don't think there's more information that needs to be gained on those. And so could we deprioritize those kinds of reviews to focus our resources on things that there are larger questions about. So we absolutely are working on updating that guidance document and accomplishing those things to try to more efficiently and effectively use our resources when it comes to reviewing the recycled plastics. So hope that will be coming relatively soon, and that is the government relatively soon.
We have a question, Jennifer.
So I have a question, and it might show my naivete on the topic, in regards to advanced recycling. And that is, it's really kind of a two-part question. One is, what's the scalability currently? Because it seems a rather resource-intense process. And then the part B to that question is, what is the sustainability of that approach? You are able to utilize more plastic products and break them down into virgin material, but it's, at least from a non-chemist perspective, it seems to be a little more energy intense. So you have this interplay of able to recycle more, but at a higher cost. And so I'm wondering how that dance plays out.
Thanks. I'll talk about the scale question first, and the bottom line to that answer is right now, when I look at chemical processing and processing unit and hydrocarbon chemistry, the thing that's limiting scale right now is feed, access to feed, getting it to the right location. I do work for ExxonMobil, so we're not only a chemical company, we're also an oil and gas company. Just for perspective, if you look at all the plastic that's made in the world, then you look at all the crude oil and gas that we process, it's orders and orders of magnitude higher than plastic. So I don't worry at all as a chemical engineer about being able to scale the process technology for advanced recycling. I do worry about access to feed. The second question with respect to energy intensity, I always have to qualify that with it depends where you draw the box. I didn't give a full answer before, so I'll correct it now. When we can use GHG emissions as partly a surrogate for energy intensity, and I want to qualify that with our analysis on our advanced recycling technology looked at cradle to gate. And so it looked at cradle to gate, extracting crude oil out of the ground, refining it, converting it to monomer, converting it to polymer. Or it looks at hydrocarbon feedstock conversion to products. When you do that on a plastic, we considered the cutoff method and starting with the plastic at zero, and that's how we did our analysis. And when we did that and compared it on a feedstock and on a product basis, again, it looks about the same, or advanced recycling is directionally better, but you have to compare it on a cradle to gate basis.
And I was just gonna say, like, to the point about feedstock, if we're looking at post-consumer recycling, think of it as a reverse logistic problem. So basically you have to pick it up from everybody's house in the country, pull it all into a single MRF. It's still gotta be sorted at the MRF. The mechanical recycling material can get diverted, and then this stuff then could get diverted to a chemical recycling facility. But it's still quite an intensive process to collect it all and sort it all. So, hence the limited feedstock we need. And it's also a chicken and egg problem, right? So we're not gonna collect it unless there's a demand, and then they're gonna not want to build the facility unless they know that the feedstock's there. So, it's kind of like a fits and starts kind of thing.
Can I add a comment here and then a question actually? Online, yeah. So just another thing on the feedstock, something that hasn't been mentioned, but I think is really interesting is that, there are a lot of companies whose entire job is to aggregate feedstock, right? Which I think was alluded to. So, that's also a new emerging market, our feedstock aggregators. And I think you'll see more and more of that. But just as a question maybe for Jennifer, and I might have missed this, do you have co-products that you sell that are not monomers that emerge from your advanced recycling process and sort of offset other costs like BTX? I might have missed that in your presentation.
We do have byproducts that we make from advanced recycling, meaning it's not 100% conversion to monomer. I can't think of a hydrocarbon process that does have 100% conversion. So yes, we do have byproducts that we make. And I want to add to the feedstock. I gave kind of a dire answer. Oh, it's feedstock. And for that reason, and you'll see this with a lot of folks that have aspirations in advanced recycling, we are partnering with those feedstock aggregators, as were mentioned. So specifically for ExxonMobil, we've created a joint venture called Cyclix, whose sole purpose is go get feed. And we're, an example is we're partnering with the city of Houston, Cyclix, Lyondell-Basell on a facility that will take the MRF plastic product and then get that ready for advanced recycling. So it's just an example of this, I love the chicken and egg comment because it's completely true and recognize it's just very nascent right now. Do I envision a world where in 10 years this has scaled up and we've figured out the sorting and the collection? Absolutely. That's what we need to aspire to.
Hi, I do a fair amount of work watching consumer reactions and consumer perceptions. And as it relates to, this is more so a social science question, but as it relates to recyclability, the recycling concept has had its own fair share of headlines lately. More specifically, how much of the recycling waste stream actually ends up being recycled. And a lot of what you do is also predicated upon consumers continuing to value and celebrate recyclability product characteristics. What can we do in order to ensure and accelerate the consumer uptake and demand for recyclability so that it ends up being that feedstock that you need?
I'll let Jennifer talk about what she needs for her feedstock. But from our perspective, it is important to be honest with the consumers. So when we see material that there's a lot of desire by the packaging goods companies that their packaging goods are recyclable. They might have chosen the best packaging for their product, and it might have the best environmental profile, but it might not be recyclable. But yet there is a big desire by a lot of those companies to label those as recyclable. And that's one of the things that, you know, we try to be extremely clear about, that what can and can't be recycled. And so to avoid any misperception that we're not taking stuff and recycling it if there's no end market. And that's part of the reason why we go through, it's gotta be not just collectible, sortable, but we have to be able to collect enough of it that we can interest in end market, and then the end market's gotta be there. So, you know, if you're doing like a small product like pouches, it's gonna take so much of the material before you're gonna be able to even get a bale of it together. And so when you go for like really small products like that, it's really ends up being a lot more challenging.
I think your consumer education and consumer comment is spot on. I actually, in my world, I am very heartened by the conversations I have with consumers about the positive intent that I see. People want to recycle, they want to do the right thing. Where I would like to see more progress is on the regulatory front, in accepting that there's not one solution to this. When you look at, you know, materials value chain, I'm not even just saying plastic, but it can be metal, glass, paper. When you look at materials value chains, it is complicated when you look at end of life. And so there's not a silver bullet, there's not just one thing. I think we need to make sure that recycling encompasses all the solutions and that multiple technologies are recognized as recycling, such that we can incentivize this new technology development such that it can now be on par with what we've been doing for decades and decades.
All right, we have one more question online here. Within the pyrolysis process, does this degrade PFAS-type molecules / enable them to be removed with cracking afterwards?
So what we have found in our process is typically, yes, the PFAS molecules are degraded by pyrolysis. What we have found is that it's degraded by pyrolysis, and then what I would say is subsequently degraded by the processing steps that follow, the things like the hydrotreating specifically, and multiple conversion units. And so when we look at it holistically throughout our whole processing chain, and you look at, I'm converting here, I'm converting here, I'm converting here, I'm hydrotreating here, most of what we see is that the PFAS is, goes from an organic, like a fluorinated carbon, to what we would call a mineralized inorganic. So it might show up as hydrofluoric acid, which then gets neutralized in the wastewater, for instance.
Can I just add another comment on that one, if I may?
Please, go ahead.
Yeah, sorry. Just thinking, a very interesting answer. I guess this is just a very active area of research in the academic community, just to give maybe a broader perspective. So just something to note is that because there's so many different PFAS compounds, depending on the length of, let's say, the alkyl chain, if it's a perfluorinated alkyl chain, right, which is typical, the temperature at which pyrolysis will defluorinate will vary by hundreds of degrees. So I think this is a really interesting area, and would love to see, the type of data that's going to emerge over the next few years from both academia and industry.
This question is for Professor Van Lehn. Is your strata process economics done based on post-industrial feedstock?
Yeah.
And
Sorry.
if that's the case, okay. Do you see a future for post-consumer as a feedstock, and what would that look like?
So I'll add several comments. First is I was really hoping someone would ask me more about fugacity. Okay, it's my favorite topic. It's coming up with an exam next week, but all right. So a first comment is that the analysis that I showed you was based on actually for that specific feedstock of just that one material. Now, I can't disclose how much of that material is available, but from our collaborators, there's enough material for that one feedstock or something similar enough to it from post-industrial sources to meet the values that we were looking at, and hence that was our economic analysis. Now, I also want to mention that I frame STRAP as a selective dissolution technology. There are multiple other solvent-based technologies that are currently being commercialized, either in Europe or in the United States. In the United States, a company named PureCycle has started they launched their Ironton processing facility in 2023. They basically purify polypropylene using a supercritical fluid. They do that at scale from mixed feedstocks. So to your point, there are examples of existing commercial entities that have a similar but not identical process that's being done at scale. So certainly the economics are there. They've had some operating issues that aren't worth getting into. As we look at sort of the broader challenge for our techno-economic analysis, you've hit on exactly the issue, which is feedstock variability, which is also what the other panelists talked about. If we're trying to aggregate feedstocks from various different places, we can't turn our plant off and on to change solvents to deal with different feedstocks. That becomes economically unviable. So the way that we've planned it out in terms of our own internal thoughts is, in looking at sort of supply chain optimization, is we'd have different strat plants located in different areas of the country to target different feedstocks. And those feedstocks would be sourced from, would have to be rich in specific polymers for it to make economic sense. So great questions, and certainly an active area for us to think about.
I have one more question, if I may. And it's kind of a social science question as well. And I kind of saw it in your presentation, Craig, when you started out. There was the headline about all these food additive chemicals found in food. And to the average mom, when they see headlines like this, they get scared. And we're rightly doing a lot of research on these types of issues. And then we're publishing papers, and then the papers get picked up, and then Elizabeth Anderson, our communications person, gets a call from the Washington Post and has to deal with this. And so one of the big concerns that I have is that although the research that's being done is really good and really important, it also, unless it's put in a proper perspective, it scares people. So what do you think we can do to help alleviate the fears of consumers where it may not be necessary?
That's a really tough question. and usually what we recommend to a lot of the folks that we work with is that, your materials are compliant with current regulations. And of course, the risk is never zero. And the problem challenge, I guess we'll say, is that with any new instrumentation that comes out, we can detect more. Right. And by more, I mean we have more positive counts. And so as we chase zero, because there's no such thing as zero, that's where a lot of the concerns can come from. And so, you know, this would go back to actually the toxicologist and to say that, you know, at this concentration, under these levels, you know, there's really no effect on the human body. Unfortunately, with, you know, the hundreds of thousands of chemicals that are available or being used in plastics and in paper as well, you know, there's a large data gap. And, you know, in that recent publication that you know, from the Food Packaging Forum, they say that, like, hey, you know, we know that these additives are being used, we've detected them in the bloodstream, and we're missing data on a lot of these areas. As far as trying to educate the consumers that this is not a concern, that's going to be a real challenge because we don't necessarily know if it is or not. Right. You know, and you know, one of the things that we always say, again, with chasing zero with a lot of our companies that we work with, is that, you know, don't ever say free. That the answer is zero, right? I mean, and so, you know, we've seen people go after polymers for BPA that have never once had BPA in it, and so it creates a lot of headaches. But the education piece would hopefully come from, you know, we have more information about the toxicological effects of some of these chemicals and the migration to go along with it, so that way, you know, with what Dr. Fischer was saying too about the half parts per billion of exposure, you know, hopefully we can combine all of that and try to convince them of that. But that is a major challenge.
Yeah, and maybe Sean, from a FDA perspective, do you have any comments on that? Because again, you're kind of at the front line with consumers as well on these kinds of questions. What would your thoughts be on that?
I would say that, you know, with FDA, we probably need to do more work to, you know, get our message out about what we're doing to ensure the safety of the food supply. And that's not just limited to, you know, recycled or even just food packaging. You know, if you, with this reorganization of the Human Foods Program that we just undertook, there's been a lot of different focuses that have come up. One of them is looking at the post-market assessment of chemicals in food. There was a public meeting on that just last week. And if anyone happened to have listened to that, you know, there was a lot of concerns expressed about different aspects of the safety of things that are in food or in contact with food. And I think FDA needs to do, you know, could stand to do more work to get, you know, to assure consumers that, you know, the things that we are doing to ensure that, you know, the safety of food and substances in contact with food. So there, some aspects of it are, you know, effective messaging. And, you know, we're also, you know, learning ourselves still. I am eagerly looking forward to the work Greg mentioned there at the end, that he said, ask him again in a year. I'm eagerly looking forward to the results of that work, to see what comes from that, to help inform, you know, how we move forward, especially in particular for recycled plastics.
I think we're ready to close the panel session here then. So let me end by thanking our speakers again today. Fabulous presentations. I thought it was really great. So nice round of applause for everybody. And I'll also thank the audience for some really fabulous questions this afternoon. So thanks very much, everybody. So here endeth the session. So.
Thank the speakers and the audience for staying to the end.
Yeah.
And also, I wanted to just mention that we do have a reception at 6 o'clock across the street at the Graduate. So please come if you're free. And then there's dinner at 7.
Okay. Right.
And thank you again.
Thank you. All right. Well done. Really good.